Today is a special day. Today we can finally write our first line of code, or rather first block of code in our case. We'll start with alarm management part. Naturally that in control application we need to detect abnormal situation and somehow handle them. Shall we start? PLC control application as a whole consists of separate program organization units, or POUs. It's a good practice to have a separate POU to handle some logically separated part of the control application. In our case, separate POU to handle alarms. Let's create one. Right-click on Application, then Add Object, find POU in the list, select it, and click Add Object. In the next window, software will offer you to select the type of POU. In our case, it's program, but you can also create function block and function. Then we give our program a proper name. And finally, select the implementation language. We can use any from the available list, but for beginning, I would suggest something like CFC or FBD. It's a bit easier to understand. But don't worry, we will get back to other languages later. Let's open Toolbox with all our tools related to CFC editor. And now the question is, what kind of alarms do we want to handle? First, add input element from the toolbox. Then double-click on it, click this button on the right, expand IOconfig global mapping, and here we can see the list of mapping for the PLC I/O channels, which we have done before. We want to select supply network relay signal. Hit OK, enter. Now the question is, why do we need to do something with the signal that is just coming from supply network control relay? If we look at the schematics, we can see that relay has a switchover contact. And although schematics says to connect wire to normally open terminal, practice shows that it could be a major source of confusion between electricians and programmers. That's why we need to have a quick way to switch inside control application between NO and NC type of contacts. In general, with a big project, you would want to have such functionality for every discrete signal coming to or from PLC. But we're learning here, and let's do it only for supply network control relay and VSD fault relay. So we need to keep input signal if it's normally open and inverted if it's normally closed. Let's add additional input, which will serve NO/NC indication purpose, and type boolean value false, which will stand for NO. And then we need to use this box to add the operator exclusive OR, which will give us needed behavior. Go to keywords and then find XOR operator and hit enter. Next, we want to store this inverted or not inverted signal somewhere and later use it in other parts of the program to take some actions in response to the fault. And the usual way to do that would be to use global variables. In Automation Builder, it is done through the global variable list. We right-click on Application, Add Object, then Global Variable List, give it a proper name, and click Add Object. Now, if we go to Alarms, we can create variables which will be accessible from any place of control application, and at the same time logically grouped as alarm-related information. Try to keep your GVL tidy and clean. Add there only variables which must be accessed by other parts of the control application. Keep them logically grouped. Try to write value into global variable only in one place of the control application. To add variable to the alarm list, we simply type the name, then colon, variable type, in our case boolean, and then semicolon at the end of the line. Let's go back to our program and write output of XOR operator to the newly created variable. Drag output element from the toolbox, get into variable selection, and then find supply network fault in application alarms. Good. Now another kind of problem we have is that type of relay contact is hard-coded. So if we needed to change to NC type, we would need to type true instead of a false, and that's not possible without changing the control application and then uploading it to the PLC again. Then let's create another variable which will hold this value, right? Well, yes, but local variables created inside a program or variable in GVL do not keep their values when PLC is powered off. They will be reset to their default value, false or zero depending on a data type. To handle this kind of problem, SC500 PLCs have persistent variable list, special kind of global variable list stored inside non-volatile memory. Right-click application again, add object, and then find persistent variables. Give it a proper name and add object. Now if we open it, we will see that it looks exactly the same as GVL we have created before, except it has two words in the header section, persistent and retain. Retain will keep variables from losing its value during power off. Persistent will keep variable values during project download to the PLC. Now we create variable the same way as before. X supply network relay contact. Type bool, semicolon. Go back to the program and instead of false value, use variable we just created. We can type persist, control plus space to autocomplete the name, then dot, and then select from available elements of the variable list. You may have noticed that variables which are coming from variable list have these three horizontal lines, pictogram, and name doesn't have GVL name. If you right-clicked on empty space and unchecked hide namespaces, you will see that software will show you the full variable path. Sometimes it might be useful, but usually you want it short and clean. In many cases, it's a good idea to have comments inside your code. Maybe not in so simple and obvious case like here, but nevertheless, let's add it just for practice. As I mentioned before, we also have VSD fault relay, which we need to handle the same way. Go to alarm list and create a variable. You don't always have to type everything manually, you can press Shift F2 and use auto declaration wizard. Type the name, then type and click OK to create the variable. Repeat the same with the retain variable list. You can copy, paste and edit if you find it easier. Then go back to program and recreate program in the same manner. We also have this global fault output signal, which is supposed to be activated in case if any alarm or fault occurs. So we add OR operator, connect output to the DO mapped variable, and then connect fault variables to the input of OR operator. Are those all alarms we would have for the whole project? No, not really. We'll also need to handle various sensor-related alarms and pumps abnormal behavior. But for that we would need to have analog signal scaling sorted out, which is a topic for the next episode. Now, another important part of control application is tasks. If we go to task configuration, we can see that there is a task called task, very original, I know, has been created by default. What is a task anyway? Task is a pattern in which controller runs this or that piece of code. Typically, controller runs control application cyclically with predefined cycle time, which is in our case 10 millisecond interval. In other words, each 10 millisecond, controller will read inputs, execute everything inside specific task, and then results of code executions will be written to the outputs. Programs which are executed inside task are listed in this section below. There is a PLC-PRG program created by default when you created project from AC500 template. And we can actually add our alarms management program here in order to make controller executed. It will work just fine, but I would suggest doing it a little bit differently. This way will give you more flexibility in the future. So we go to PLC-PRG program and call alarms management program from here by simply typing the name, adding open and close parentheses, and then as usual at the end of each statement, semicolon. And that would be all for today. Thanks for being with us. See you in the next one.